I'm Chris Foley with P4 Infrastructure. We're also here in Milwaukee, Wisconsin. And I want to now turn our attention to how the PaveDrain installations that you currently have and those that you may be planning can be turned into actually smart BMPs and make money. So we're going to focus on three of our products. One is InfilTracker, one is InfilTracker RTC, and they are now going to be integrated within, as you'll see, the PaveDrain system. Now, there are three main structural BMPs that are out there, best management practices for stormwater management. The first is permeable pavement, and today we're focusing on what we think is the best in breed, PaveDrain. And then we're looking at wet detention cisterns and also biofiltration systems. Now, a permeable pavement gallery is really nothing more than a tank, and there's an awful lot of questions that arise as a result of these BMPs being implemented. How fast is the storage gallery discharge? Does the subgrade infiltration rate change over time, or what is it currently? How much stormwater are you capturing? And as Doug mentioned, when should I perform maintenance? And then last but not least, what we'll see today is, can I increase the efficiency of an existing and new BMP using technology? So what are these questions now have answers that have monetary impact, as we'll see. And the P4 PaveDrain system that we talk about today are going to have us answering some of these questions, saving money, and actually making money. So what is the PaveDrain P4 system? Well, as you know, and you're here today and have seen it before, the PaveDrain system is this articulating concrete block surface. And what we've done at P4 is created a block that includes a computer, solar panel, battery pack for running computers, and also a cellular transmission system for a water level sensor that is beneath and in the storage gallery below the surface. Now, there's an under drain often present in these systems, and as what we'll see the InfilTracker RTC is a real-time control valve that is tied into this system to be able to discharge and retain water within the gallery. We measure rainfall locally at the site, and what you'll see in the image is a rain gauge and a computer that's on top of the building, and this happened to be Cudahy City Hall that we'll show in a minute. And that is basically a rain gauge that tells you how much rain falls. Now, what happens below the pavement? Well, we started out, and Doug walked you through a series of experiments. We started out with what we call our PaveDrain Patio in Brown Deer, Wisconsin. And this is a 2-foot deep storage gallery. It's carved into very, very, very stiff clay. So it's a 10 by 10 patio, and we have 2 of our sensors installed. And there's been many rain events that have occurred on this surface from October 2019 to present. The surface runoff that goes to this is a little bit from the adjacent parking lot, some of the direct rainfall that falls on the patio surface, and then also some downspout discharge from an adjacent building. We have the rainfall gauge, or Rain MX as we call it, on the building next to the patio. And what you see in the graph is a couple of rain events, and there's many more as I mentioned. These rain events do indeed cause infiltration through the surface into the storage gallery below. And as I mentioned, this was very, very stiff clay, and the infiltration rate is really quite slow. And you would expect this to be on the lower end of wind slam models for infiltration rates on the order of 0.01 to 0.015 inches per hour. But what you can see here is that rain events do indeed cause rain and stormwater flow through the surface into the gallery, and the gallery is indeed discharging, albeit at slow rates, and that's expected given the material that it's founded upon. Here's another one. We do have an implementation of 3 of our sensor systems in Cudahy, Wisconsin that have been active since January of 2020. And the rainfall gauge that you see there is on top of, pardon me for going backwards for a second. So I'm sorry about that. Had to admit someone to the meeting. We now have the Doorman Alley in Cudahy. And the rainfall gauge, as I mentioned, is on top of City Hall. And there are 3 sensor systems located throughout the city, one of them in an alley application. And what you see here is a series of rain events between January 20th, 2020 and March 20th of 2020. And what you see is the infiltration of the water is happening through the surface, as well as being drawn down by underdrain. So this is a typical application of underdrain below or within the storage gallery. That initial very steep slope is water that is going through the gallery into the underdrain. And then there's a slightly more shallow slope where the stormwater runoff is actually infiltrating into the ground. And what's interesting about this application is it's another one of those that tends to have irregular maintenance associated with it. And in the lower right corner is the joint, what the joints look like. And so Doug has shown some instances where this is a plugged surface by many implementations and applications and visual evidence. However, what you can see is there is water going through the surface, going through the gallery, and discharging from the gallery on a regular basis with each rainfall event. There is, adjacent to this application, a lot of run-on debris through mulch, soil, etc. That's the perimeter of the alley that you can see in another image. But this gallery is acquiring stormwater flow through the surface regularly, and we're going to see how this continues into the rainy season coming up. Now, how does P4 look at this system, which is a permeable pavement system? Well, we look at the permeable surface as basically a funnel capturing water. We look at the storage gallery below as a tank that stores water. Now, according to many guidance principles and standard guidance documents, the underdrain presence within these results in a pollutant efficiency of 65% for suspended solids and 35% for phosphorus or total phosphorus. So when that underdrain removes the water from the gallery, it is not as efficient as it could be. If you're infiltrating into the ground with all the water in the gallery, you can have 100% pollutant removal, both suspended solids and phosphorus. So what the P4 systems do on the right is, number one, it tells you how much rainfall lands in that funnel. It tells you how much water is stored below the funnel. And it also tells you how much water is leaving and the rate at which it leaves that storage tank. So the concept behind the RTC, or the real-time control system, is that we actually control the water leaving the storage gallery. When it is draining through infiltration, we get 100% removal in suspended solids and phosphorus. And when we have to open the valve and drain through the underdrain, we're doing it at 65% effectiveness for suspended solids and phosphorus. So we maximize and optimize the pollutant treatment capability of the storage gallery and the system. Now you can imagine that these things are placed throughout an urban watershed. And I just took an instance of what we have here in Whitefish Bay, Wisconsin, near Lake Michigan, where there are two TMDL, or actually one TMDL challenged body of water, the Milwaukee River, and then there is another outfall and discharge location in Lake Michigan. So you can imagine these funnels and storage tanks throughout Whitefish Bay. Now, how do you perform maintenance when and where needed throughout these BMPs? And number one, are all of these owned by the municipality? Some of them are privately owned, some of them are not. Some of these might be constructed as part of MS4 compliance needs. Some of them might also be constructed as part of TMDL compliance. So what we're doing with the P4 system is we're tying all of the PaveDrain BMPs together in a unified approach to stormwater management that includes maintenance. Now, what you see here is how you look at this within the P4 dashboard. Now, what P4 has done is we've built a system, really a database, that is viewed through the ArcGIS, really Esri, the Esri ArcGIS interface. And this is the city of Cudahy's implementation of their 4 sensors in their network. There's the Van Norman Alley permeable surface, there is the Squire apartment building permeable surface, and then there is the installation at Cudahy City Hall, and then the Rain MX device on the roof. So if you wanted to know what's happening at any one of these devices, it's a simple hover over the pinpoint, click on it, and you can see that there is a rain gauge chart that is showing up on the right. There's analytics that are being tied to this, as well as the ability to download historical data, print reports, and generate alerts. So P4 has this dashboard, I should say, in implementation with Cudahy, as well as the city of Appleton, which is an underground storage cistern. And we are reviewing these and developing the dashboard with their input so that it's the most effective for the municipality's use. Now, what is this EPA compliance, MS4, TMDL stuff? I'm sure many of you are familiar with this, but the way P4 views this with their systems in mind is that we have to achieve an overall goal of Water Quality Act compliance with whatever we do with stormwater best management practices. Some of these are privately owned BMPs and they're already built, An example, maybe a big box parking lot. Many of these are publicly owned and already constructed. It might be a municipal parking lot. It could be an underground storage cistern. And some things need to be built in order to complete the EPA compliance circle. And this is what we call the water quality compliance gap. And what the P4 systems allow you to do is, number one, increase the efficiency of your existing PaveDrain installations, and then target additional constructions of these systems to close that water quality gap very quickly. And what our InfilTracker RTC product does is it reduces the cost per pound of pollutant removal significantly. And it does this by utilizing infiltration from the storage gallery when possible, and it utilizes opening the underdrain when needed to ensure that that gallery is discharged according to the DNR regulation for the next storm event, 72 hours, for example. So this is an optimization and a control system to help you reduce the cost of these BMPs. Now, retail pricing and return on investment. When we look at this from a point of view of an individual private property owner, example, a parking lot, many times there are going to be stormwater utility fees returned to that property owner from a municipality that is hopefully receiving benefit with their MS4 compliance in keeping stormwater where it lands. And in the case here, it's a relationship between Easy Storage and the city of Cudahy, where the stormwater utility fee is essentially $7,900 per year for Easy Storage. Now, what the city of Cudahy does is it actually returns $6,700 back to Easy Storage for disconnecting from that MS4. And at the same time, what happens is Cudahy has to inspect the BMP. So they withhold $1,200 a year to do that inspection. So the InfilTracker device, and you can see it here on the left, it's a PaveDrain block with a computer embedded inside, a battery pack inside, and a solar panel integrated into the surface, as well as an InfilTracker sensor next door, and then of course the Rain MX system to give you rainfall measurements. Those two devices together are $6,800. And an affidavit of maintenance, in our opinion here, is the InfilTracker system. If you want to print a report showing you've infiltrated stormwater, you can print a report and it's very easy to do so. So the return on investment for the devices is essentially a year for that stormwater utility and certainly the private property owner that installs that. The net income after you recover that capital expenditure is that now hopefully fully returned $7,900 per year, plus or minus, I should say, the $300 per year in order to view the data, print the reports, etc. So P4 is beginning to bring the largest and the newest of technology economically into these systems to not only drive the efficiency of past construction, but also affect the future construction and do it more economically. So with that, that's P4, that's where we are, P4I.io, info@P4I.io if you need further information. And I'll turn it back over to Doug.
Thanks, Chris. Fantastic. One of the things we looked at when we were talking with Chris about getting this started was we'd like to do a lot of analogies. And one of the analogies we started off with in terms of maintenance is if you had a light bulb, would you change that light bulb if it didn't need to be changed? And the answer is always no. Well, why go out and do maintenance just because it says so on a calendar or what you need to, or somebody wrote a rule and says we need to do this? Let's do it when it needs to be done, but we need something to tell us how to do this. So what we've already seen is the debris and clogging happens from up gradient to down gradient. And wouldn't it be neat if you had a system out there that said that a street, smart street, if you will, that said, hey, I need a cleaning done, and knowing full well you can take it from something as dirty as it is on the left to on the right. So it's really quite revolutionary way of going about this.